Today we're going to talk about lesson 30, which talks about transformations of a quadratic function. So a quick reminder, quadratic means that we have an x squared term, and our graph is going to be a parabola. So just in general, any transformation means that we're taking our graph and we're going to change it a little bit. So you could change the shape of the graph by stretching it or compressing it. You could just move the graph around. So you could move it to the left 3 units or up 7 units. You could also reflect the graph. So any of those are different types of transformations, and we're going to look at all of those. We're going to look at y equals x squared first. I want to find the vertex. So we use our opposite of b over 2a formula to find our vertex. We don't have any b terms, so we have opposite of 0 over 2 times 1. Well, we know 0 divided by anything is 0. And if you plug 0 back in, we get our y value, so 0 squared is 0. So our vertex for y equals x squared is 0, 0. And y equals x squared, if you recall the word parent function means it's the simplest version of that type of function. And y equals x squared is our parent function of a quadratic. It's always centered at the origin, and it's always going to be facing upwards. So anytime you see y equals x squared, you should have a good visual as to what that graph looks like. Next, I want to look at the equation y equals x minus 3 squared. I want to find the vertex of this. Well, in order to find the vertex, we're going to have to write our equation in standard form. So we have to FOIL x minus 3 squared. When we FOIL it, we get x squared minus 6x plus 9. So now we can a little more easily find our vertex. So opposite of b over 2 times our a value. The x value is 3. To find the y value of our origin or of our vertex, we have to plug it back in to our equation. So 3 squared minus 6 times 3 plus 9 gives us a y value of 0. So our vertex for this function is 3, 0. And if you compare that to our parent function, so we have 0, 0 and 3, 0, this function is shifted to the right 3 units. So that's a transformation we'll talk about. But keep that in mind. The next thing I want to do is find the vertex of this function. So y equals x squared plus 4. Again, our vertex formula, opposite of b over 2a, our b value is 0. If you plug 0 back in, you get 4. So now our vertex is 0, 4. Think back to our parent function, 0, 0. You would have to go up 4 units. So x squared plus 4 is vertically shifted up 4 units. So in a minute, we're going to look at a couple helpful hints, how you can look at this equation and automatically know what kind of transformation occurs. To help us with that, we're going to introduce the vertex form of a quadratic function. So this is another way to write a quadratic function. It's obviously not standard form, but this form will help us pick out our vertex almost immediately. It will also help us to find our transformation. So I have a couple hints that will help you when you see this formula. The first one is that our leading coefficient, that a value, cannot be 0. If it's 0, you don't have any x squared terms anymore, which means it's not quadratic. Hence the name, it's a vertex form. You can easily find your vertex. So it's going to be the opposite of h, comma k. So this corresponds to the x value of your vertex. K corresponds to the y value of your vertex. Anytime you talk about transformation, the h is going to talk about a horizontal shift, which if you think to our first example, our vertex was shifted right 3 units. The k is going to tell you about a vertical shift. Again, our previous example had a plus 4 on the end, and it also went up 4. So that k tells you how much you go up or down. then a couple more things about the A value. If A is greater than 0, so any positive number, your parabola is going to open upward. And then if your A is less than 0 or a negative number, it's going to be a parabola opening down, which means it's a reflection over your x-axis. So using what we just found out about our vertex form, I'm going to give you something in vertex form. We're going to find the vertex. So 2 times x plus 2 squared minus 3. You can immediately find your vertex. Remember, it's the opposite of that h value. So -2, comma, -3 from the end part. Again, what's the vertex of this function? Well, opposite of that h is 7, and then a positive 4, so 7, 4. We're going to graph again. This time we can find our vertex a little easier. So when we go to graph a parabola, remember to find the vertex first. Well, given in vertex form, your vertex is 3, 1. So our xy table is going to be a little easier to set up. We don't have to do as much work to find that middle point. I put the vertex in the middle again, and then picked a point below and picked a point above, and then picked a point below again and another point above. Notice your y values are also symmetric, so I went ahead and graphed those over here. Our a value is a +1, which is why this opens up. A little more with the graphs. We're going to talk about maximum and minimum values. So the other day I talked about the vertex either being the highest or the lowest point on the graph, which correlates to maximum and minimum. We just talked about if your a value is positive, your parabola will open up. And if your parabola opens upward, that means you're going to have, your vertex is going to be a minimum. So our parabola opens up. That lowest point, our vertex, is going to be the minimum of that function, meaning there's no values that are going to be below that parabola. On the flip side, if your a value is less than 0 or negative, it will open down. And when that's the case, your parabola will have a maximum. So that vertex will be the maximum value. In general, when we talk about our max and min values, we're generally referring to the y value of the vertex. We're more worried about what is the height of that vertex. So the y value would be the important part for the max and min values. There are a few other transformations that I want to talk about. So earlier, when we defined what a transformation was, I said that you could stretch or compress, and we've talked about these with some other functions before. But we have a vertical compression, which means you're still looking at your a value. If the absolute value of your a value is between 0 and 1, so a fraction, then we're going to be looking at a vertical compression. Vertically compress is going to smash it, making it wider than your parent function. If the absolute value of your a is greater than 1, then we call it a vertical stretch, meaning you're pulling on the top, stretching it up, giving you a graph that's going to be narrower than the parent function. I'm going to give us a function, and I want us to list the transformations. So here we have a quadratic function with a 3 out in front, a +2, and a -5. So we're looking at 3 different transformations. The first one, that 3 is greater than 1. Greater than 1, so it will be a vertical stretch. The 2 on the inside means that we're going to go 2 units to the left. And then the -5 on the bottom is 5 units down. Here we have a -1 in front, which means it's going to be a reflection over our x-axis. And the -4 means we're going to go 4 units to the right. Here are a few other things that I would recommend looking over to finish off this lesson.